Hi guys, it's me, Yani, and in today's video we are going to program a controller. This this controller can be applied in many applications, and in this video it is one of the basic applications that we can use.
So now we are here in the MPLAB IDE. This is the program where we are going to program our IC. First, we are going to create a project. So click here, this folder with plus sign. So there. So it is microchip embedded and standalone project. We don't need to configure it in any other format, so we just click next. And then here we are going to declare which IC are we going to program. In this case, we are going to program a PIC16 F18875. So we type here in the device PIC16 F18875. As we can see, there it is known here. So we just click it. So now the device is PIC16F18875. This is when everything is set, so click next. Now we are going to select which compiler are we going to use for this program. So I choose the X68, in which we are able to program our IC in C language. And then next. Now we are going to name our project. For this project, we will rename it as Experiment 1. When since it is renamed, so we're gonna click Finish. And now as we can see, all the folders and source files, header files are already imported. To make things easier, we should click this icon, the MPLAB code configurator. This conf code configurator make uh, it is make programming more easier, since we are going to declare using GUI our inputs and outputs. So click save, or you can rename it to another file name, but for now we are retaining it as my config for this project. So click save, and now we are here in the MPLAB code configurator, where we are going to set the pin on which we're going to place our input or our output. But for this experiment, we are going only to set up our input. So first, we should know what kind of package of IC do we have. So in my case, I have PDIP P40. So I'm going to click it here. So now, as you can see, the layout of the IC changes. So this is my reference when we are going to place our components such as LEDs. And now, This is the pin manager. As we can see, there are number of pins. Port A 0127, port B 0127, port C 0127, and so on. Now, we will declare our output pin, which is served as the LED in port A in pin 4. So now we can see the GPIO and IO RA4 is in pin 6. So we should remember, you should always remember the pin number you are going to set, especially in declaring ports of inputs and outputs. So now our output is in pin 6. Next, we are going to rename uh, our output pin. So we are going to pin module. As we can see, there is custom name. So for this, we are going to rename it as LED underscore D2. Sorry, here. So we are going to rename it as LED D2. So since we are going to use a digital output, we should uncheck the analog. This means that our output is in is a digital one. So now we are going to our system module to check some settings. Now as we can see, this is the setting for the oscillator. Since it is default, it is alright, but for this to but if not, make sure that the for this internal oscillator, it should be in high frequency internal oscillator or HFINTOSC, and the internal clock for this oscillator is in 4 megahertz, and its clock divider is 4. When we scroll it down, low voltage programming enable should be marked check. Now everything is set, so we should click the generate button here to generate this configuration. As we can see, saved configuration to file, so means that the generation of this code is complete. So now we are going to program the IC with our very uh, own code. So click here in projects, then source files, then the main C. This is the file that we the this is the file where our program is being placed. So click it here, and now we are here to the main.c. So enable, but for this experiment, we are going to make our LED blink with a delay of 250 milliseconds. So to do that, we should write, we should type double underscore, so underscore underscore delay underscore ms, since it is set in milliseconds. So open and close parentheses, then write 250, which indicates 250 milliseconds of delay. So then semicolon to indicate that is the end of that row, to end that is the end of that line. Now to make the LED blink, so we will type the name of our output, LED underscore B2. And then to create another command for blinking, which is known here in the MP lab as toggle. So underscore toggle. Sorry. Then open and close parentheses to indicate it is a function, and then semicolon. So as we can see, we will use the toggle makes the LED blink with a delay of 250 milliseconds. Now, this is the code that we need for the program. We should it is we should compile it now or build it. To build this program, click this hammer, which is the build main project, or with the shortcut key of F11. So we will click it. So you can see it is starting to compile. Now, as we can see, the build is successful. This means that the program is ready to be imported in our IC. This is the debugger used for our IC. This is PKIT3 by Microchip. As we can see, it is connected to my computer, and that is why the LEDs are already lit up. This arrow indicates pin 1. So, pin 1 indicates it is the reset pin or the clear pin. So we are going to connect our 5 header pins to clear. And now as we can see, pin 1 has a brown wire. This is the reset pin or the clear pin. The pin 2, which is the red wire, it means it is the VDD. The orange wire is the VSS. The yellow wire is the data pin. And lastly, the green wire is the clock pin. So this is the connection of our IC to the PKIT. First, we ground the LED, which is LED serves as the output. Then the green wire, this green wire connects pin 1 of the PKIT, which is the clear pin, to the clear pin of the PIC 16 F18 875, which is also in pin 1. The VDD, which is represented by this red wire, is connected to the pin 11 of the IC. The VSS, which represents the blue wire, is connected to the pin 12 of the IC. The pin of the PKIT, which connects the pin 40 of the IC using the yellow wire, and the orange wire connects pin 39 and the clock pin of the picket. And this purple wire connects pin 6, which we configured as an output of the IC, connect, connecting the output itself, which is the LED and the resistor. Our IC. To program it, we use the MPLAB IPE or MPLAB Integrated Programmer Environment. So, in the device, we should type the model of our IC, which is the PIC16F18875. So the tool should be the picket. As we connect the picket, it automatically detects our device. So now it is already connected. So in able to work or to work it properly, you should go to settings, advanced mode, and if there is a prompt that requires you a password, type microchip. And now go to power, check the box with power target circuit from picket tree, and voltage level should be set at 3.125. Then back to the operate tab, we should select the hex file of experiment 1. So click browse. As we can see, this is the hex file of experiment 1. So this is the exact location of that hex file. Experiment 1, this, default, production, and now we can find the hex file of experiment 1 that contains our program. Then open. So now here we can see that the hex file is loaded successfully. It is it it is ready to be uploaded on our IC. So click program to program our IC using the hex file selected. Now it says programming. It's still loading, and now programming complete. Since the program is being uploaded in our IC, we can now test it out. So to test it out, disconnect the VDD from the picket tree and connect it to the 5 volts. And the VSS was also connected to the picket tree, and should be connected to the ground. And now as we can see, the LED blinks with the delay of 250 milliseconds, or it toggles the LED with a delay of 250 milliseconds. We see how this program works. What if we change the delay into 2 seconds? So to change that, we should type here, instead of 250, it should become 2000, since there is 1000 milliseconds in 1 second. This means that the delay will become 2 seconds and the LED toggles. Now, to save this program, we should click Build. And as we can see, it starts building and it says build successful. And this prompt will show. Since we already loaded the hex file of this program and now we modified it, so we should click yes to reload this program with this new configuration. And now we are going to the MPLAB IPE. So here, but before we program it, make sure that the VDD is connected to the pin 2 of picket 3 and the VSS to the pin 3 of picket 3. So now, we can program it since I already connected those pins to reprogram our IC. And now, as seen, the device is being erased. It means that it deleted the old program and now the program was complete or already loaded in our IC. Since our new program is being loaded, to test it out, we should connect the VDD to 5 volts while the VSS to the ground. As you can see, the LED has a delay of 2 seconds. It means that the blinking of the LED becomes low since the delay becomes higher.